Hello. Morning, evening, afternoon, etc., etc. Hello. Hope everyone's having a good Sunday. Slightly unprofessional for myself. I decided to reboot my machine about 10 minutes before starting the stream, and then realised I have quite a lot to set up after that. So I've just been frantically sorting stuff out. Hopefully everything's now working. If we have a few environment issues, that is my fault, and we'll fix that as we go along. I think I've got everything set up. Got my new combined chat software that seems to be working. I'm hoping someone from Twitch will say a message soon so I can check that that's integrated. Thank you. Oh, Queco, you were not the first chat today. You missed out. Thank you very much. Yes, okay, fine. So I can see both YouTube and Twitch messages in one window, which is nice. So that means I can now ignore you both fairly. I will obviously always do my best to respond to every messages. A few of the usuals rolling in. Good to see you all. Already failed this year. Well, better luck next year, I guess. Yeah, so we were doing the custom file format last time, the TLV queue, or TLV, I guess it's kind of a queue, whatever. TLV structure, type length value. So the idea is that we can have a bunch of types and then encode those in a binary format where you have 4 bytes for the type, 4 bytes for the length, and then length bytes for the rest of the data. And we can do ints and strings so far. I think today I really want to get this hopefully wrapped up. I don't really want to see this spill over to a third stream. If we have to, we will, but we obviously have not done anything graphical yet, so it'd be good to kind of get that back. Yeah, so we'll continue on it. So basically, I think a good sort of success measure for this would be to actually encode a real resource we've got. So I want to kind of see if we can encode a texture in all this. So we'll need to expand a few more types because we'll need arrays, we'll need byte arrays, we'll need to encode like a file, like also like an image type. So whether it's RGB, RGBA, etc., etc. So yeah, I think we're going to start doing that, and then we need to do the writer. So yeah, we'll get on. Oh yeah, sorry, I've got my little thing here. Right, let's. I'll press the button and we'll get started. That's my new just chatting scene in OBS, where you can see more of my mug and less of the code, which actually is probably not what people are here for. Okay, so where did we get to last time? So we got some tests as well, which is nice because this is very, very testable. You know, check if all the types are valid. We faffed around trying to build one from scratch. We need to build a writer as well, so I'm hoping we add a couple more types here, just refresh ourselves with how this all goes, a bit more mechanics, write some extra types, then we'll do the writer, and then we'll actually write a texture into it, and we'll see if we can kind of decode it and load that in, and we'll actually hopefully see something today. Yeah, let's keep going. So I'm kind of doing like the primitive types at the moment. Is it worth dealing with endianness? No, because it doesn't matter as long as the writer and reader are on the same endianness, then it will just work. The only issue is if you are going to be producing an asset pack on an architecture different to the one you'll be consuming it on. I think it's safe to say, famous last words, that it's unlikely I'm going to suddenly decide to build all my assets on like a Sun Spark system and then ship them over and then run the game on x86. I mean, never say never. I might change my dev environment, but I think we can kind of ignore endianness for now. Yeah, I think we can stipulate that that's not an issue. We could always put some magic bytes in there that say the endianness that it was on if we need to, or just say that it's always little endian, so even if you're on a big endian system, you should convert it to little endian first. Okay, so I think what we want is like a uint 8 array. So this will be our generic data array type. So this will be for textures. I guess we could. So I was thinking about doing this as colors, but then there's different color formats. There's RGB, RGBA. There's just red only. So I'm going to keep it a little bit more generic and just have a binary. Just your texture data is a binary buffer, and with that you will also encode the type with it. It is true, no one likes big endiness. Arguably, I don't know, to some extent, like, I feel it's correct in the sense that it reads the way it's laid out, but here we are. It's one of those things that I always say, it's like, I don't know why we, as, a population, couldn't have just gone, there's one way to read the bytes, we'll stick with that. It's, someone's gone, everyone's putting the bytes in this way, I'm going to put them in the other way, and now we have this horrible system where we have, two different endingnesses. It's like line endings, right? Everyone was like, CLRF, some people have CL. I think old macOS used to have just carriage line feed. Is it carriage return line feed? Yeah, some people have CRLF, some people just have LF. It's a whole mess. Allegedly, like, I don't know the ins and outs to say whether it's more efficient or not. I assume normally these things come from an efficiency standpoint rather than just, I mean, sometimes it's just people wanting to do their own thing, but I'm going to guess that's it. So auto uint8 array const std vector std uint8t. Again, because we won't know how big it is a priori, so we'll have to return a dynamic structure, like a dynamic array here. Is the font size alright? I've realised I've reset everything and I can't remember what font size was on before, so I'm happy to boost it if it's too small, but I'll kind of... oh yes, it should be your array value, thank you. What's going on? Also exciting, I've recently swapped the escape and caps lock key on my keyboard to see how that feels. So effectively the escape to normal mode is closer to my left hand. I keep getting it wrong and put myself in caps lock, which then just throws Vim way off. So you've kind of got that to contend with today as well. Right, we're going to want a implementation for this, so let's go to TLB entry. TLB reader. And then what am I doing? TLB entry, sorry. I'm really in the weeds of what I'm hoping is going to be the next video, and it's really consuming a lot of my brain space at the moment. So I'm hoping this is going to be a nice relaxing way to end the weekend, because I'm somewhat kind of up to here with it's so close to getting something good working, but I'm not quite there yet. Std vector of a vector of std uint8ts. Should that be uint8t or should that be std byte? Do I care? Do I care? I feel it should be byte array. Because it's just generic data, like the shape of it is kind of up to the user, so they might have to cast it or whatever, but that's not our problem. Also, I feel like byte array is semantically sort of more meaningful than uint8t array. Yeah, happy for people to argue it out, but that's kind of my thoughts on this. Does it matter? In the grand scheme of things, like, none of this matters. No, I mean, like, probably not. I want to kind of be consistent, and I think we've used bytes elsewhere. Why am I using trailing type returns? A great question. That probably means you're new, because someone asks that every stream, so welcome, glad you're here. It's a style that I I know exists in C++, but I've never tried it before, and I wanted to kind of try it in anger, so I thought I'll do the whole project in this and see how I feel as a style, the trailing return type. So far, I don't mind it. It's kind of okay. Yeah, just seeing whether, you know, to have it, like, it's one of those things where for me to have an opinion on it, I feel I should have given it a good go of using it first. So yeah. Okay. So we will. I think someone's dropping some knowledge on the Twitch chat about the performance of Little Endian. So I will. I'll take your word for it. It sounds good to me. Little is nice in that the least significant bit is stored first, so it's easier to recast pointers to smaller types. Sure. Okay, so let's check we've got a byte array, and then we need the size doesn't matter because we will get the size out. So I'm going to want to. It's basically the same as string, isn't it? Isn't it just the same as string? But we just the shape is different. Ooh. Is that going to work for us? Can I construct it with... it won't be a char, it will be a stirred byte. So that blends. Cool, nice. Okay, got it. Okay, so that seems pretty good. Let's just quickly, or whip up a quick test for that. So I really should parameterize these tests. I've just not bothered yet. Byte array. Byte array, and then byte array, create binary vec. Oh, we've already got our template magic from last time. And then this will be byte array value, and then this will equal to a stirred. I don't know if I can declare this in line because of the way the macros work. I seem to remember there being some issue with this, doing this before, but I think it doesn't like the braces. Yeah, it does not like that. Okay. Const auto expected equals stirred vector stirred byte oxaa oxbb oxcc oxxx. Oh my goodness, I've invented some new hex characters. Sorry, I'm still getting used to my new keyboard as well. Byte array byte array value valid, and then byte array value invalid type. Well done. So for let's try that blends. I don't know if I have like favorite language is such a weird one because I try not to get too emotionally attached to languages, which is it's easy to do because you spend a lot of time using something. It's obvious you're going to have a preference for it because you kind of start to learn it. Oh, hang on, what am I doing? I'm being stupid here. Just put the bytes back in, can't I? I've already got the vector for it. And I don't really believe in like language jingoism, one language better than the other or whatever this. I guess if you've asked me to say which one do I, which one do I prefer, I guess C++ is probably my favorite in that sense, just because it's the one I've used the most. It's the one I have the most experience in. It's the one I'm probably the least terrible at, but I don't know really, what that really says. Right array value. I'm sure I've already put this in. And then let's try putting that out as a. Yeah, I think so. I was just talking about this. I don't mind the training auto return type now. I'm kind of used to it. At the end of the day, it doesn't really matter. I think as long as you're consistent, it doesn't really matter which one you pick. I should already have vector included. So yeah. Okay, so that's fine. So I was thinking about this as well. I think I want to be kind of explicit with a lot of this. So imagine, if you will, or you don't even have to imagine, let me show you. We have a texture usage. So I'm going to want to encode. No, I don't want to encode this because the game should know. But what we do want to probably, what we will need to encode is, so actually we have to change texture a bit here. Okay. The number of channels, so whether it's RGB, RGBA, etc., etc. Because when you loaded your arbitrary binary from the disk, you're not going to know what's inside it. Also going to have to include the width and the height. So this is I'm going to create a new enum for this. So probably just RGB and RGBA to start with. If we needed other ones, we can add them. That is just a number. It's just an enum. So we could just encode a uint32t for it. But I want to kind of be explicit, so I'll probably actually have as an explicit type for these. It just kind of helps make sure that everything is correct along the way, and we're not doing, because eventually you are effectively taking high-level types and serializing them into bytes. So the more explicit we can kind of be on the way, I think the less chances there are for mistakes. Yes, I'm doing well, thank you. Hope you are also doing well. Okay, so I think we're nearly there. So let's do enum class texture type, I guess. I'm not sure how I feel about the name. RGB and RGBA. So just, yeah, do we have a three component or 4 component? Yeah, 3 bytes or 4 bytes per pixel, basically. Yes, I'm well aware that binders textures break render.doc, which is why I'm not planning on using them, because I rely on render.doc quite a lot. Yeah, texture color type. I think it's almost actually. I think actually texture format might be better. I'll plumb all this into the actual texture class in a minute. I just want to, I kind of want to make sure we can serialize it first. So let's, again, all right. Texture format. Yeah, I can use standard library. I can even use Boost. I've never worked anywhere where you couldn't use either of those two things. Although I've always worked in places where it's preferred to use the standard library first, which I think is the right choice. I think the standard library gives you good, sensible defaults for most things, and my opinion is you should reach for the standard library first, and then when you are kind of your requirements don't align to the guarantees they give you, then you kind of reach for something else. Okay. Texture format. So I'm going to start including some of the other bits of the game. So what we got? We got texture. Texture format. And then we'll go over to the entry. Put that in TLV entry. And then it's going to be very similar to the uint, excuse me, 32 one. So fuint text format. Check that it's got the size specified is indeed the size of a texture format. And then create an empty texture format, copy it in, and return it. And I'll okay. I'll add some more tests in this at the end. I want to kind of get through some of the machinery first and go back and add the tests later, because I think we're kind of happy that a lot of the mechanics of this are working. Someone on Twitch saying can't stay longer, but you want to watch this later. It's all these all get immediately uploaded to on the YouTube channel afterwards. So if you just go there later, it'll all be there, and all the past live streams are there as well. So shame you can't hang around, but yeah, do feel free to catch up with it later. I don't, but I think this is a really interesting question about interviewing in like the tech sector. I think interviewing for like engineering roles is an almost not necessarily unsolvable problem. I think it's very, very hard to do. So I think it's very easy to just kind of be generic with it. Like, if you've got a lot of applicants, you obviously have to filter way through them. I don't think leak code style questions are a good measure of you know, a candidate's skill. Like, just because you've memorized all these DSAs doesn't necessarily mean that you're actually good at the job. So when I do interviewing, I tend to avoid like leak code style problems, but I get for the big tech companies, it's just the game you've got to play. So yeah, you would probably grind those as you know, you do your research and you prepare for the interview you think you're going to get right. And if the interview is leak code questions, then sure, you would probably grind them. I don't do them myself, but I'm not applying for those kind of companies. Cool. Okay. So I think we're kind of there. So the last thing I wanted to do, actually, we probably will write a test for this. I want to add the concept of like aggregate types. So I want to have like a texture, and a texture will actually itself contain a TLV of the previous formats. So the Alexa's going off. Don't know what it wants. So that's kind of my thinking, is that the way we can kind of build up. So a texture would be a format, a width, a height, a name, and a byte array. So we would combine all of those things together. And then when you're processing it, all you have to do is just create effectively a sub TLV of those, stick it with the texture type, and then you can pass it. That's kind of my thinking. So let's give it a go. This is where I possibly need to start modifying the texture class. Oh, am I going to have to include the usage as well? I'm just trying to think how I want someone to consume this, because if I'm pulling data off the disk, so I say I want to load a resource right in the game. I want to load an albedo texture. Eventually, I know I'm going to want to put sRGB in, but also, and then if I want to load a null map, I need to mark it as data so that they don't get incorrectly gamma corrected and all that sort of gubbins. Whose responsibility is that? Is it the responsibility of the person encoding the resources to preset that? Just say, nope, here's the data you want. You know, trust me, it's normal data. Or do I want to be able to load the raw data, and then at runtime say whether it's data or not? I guess the answer is it probably doesn't matter, because I can't think of a situation where you would ever not know ahead of time. Like when I'm building out the asset pack, I will probably know whether it's data or not. So I think actually, you know what, let's just do this, and then we'll fix it later when it's wrong. All right, so entry, okay, so format, usage, texture, usage. What's going on? Usage. Usage. Okay, right. Why? Ooh, steady. Okay, so we can now combine those. Yeah, I think it is easier. Right, and now finally we can do not that. Auto TLV entry texture const texture. So let's take the usage check. That makes sense. Check it's that. And now I think, I'm hoping, what I can do is say, it's been a week since I've looked at. It's been a few days since I've looked at this, and I've forgotten all the internal structures we set out. So TLV entry owns a span of bytes. That's it. So we should be able to say. We don't care about the sizes encoded in the value, so we should be able to do auto reader equals TLV reader, and then pass into that the actual bytes themselves. Right. So what I'm saying is, if this span, rather than containing like raw data as in this, it actually contains itself another TLB, we can just reuse the code we've got to bring those out. So then we can do like const auto format equals reader dot hang on, wait a minute. Auto reader cursor equals stood ranges begin reader, right? And then we can do const auto const auto width equals reader cursor dot uint32t uint32 value. So then we can basically just pull out all the bits and pieces that we want. The TLV doesn't have a length because it's part of the span has the length itself. We're just reusing the standard because this is just a pointer. All this is non-owning. It's effectively a view over a blob of data. So you'll give the TLV machinery a big old blob of binary data and be like, hey, there's a TLV in there, and then it will basically, to minimize copying, it will just kind of move spans around the various parts and kind of shuffle its way through the bytes, and it, checking the internal state at various points. Yeah, there's no, again, because I can just do value dot length or value dot size, and I'll get the size of it. And then we can just advance the cursor. Ensure reader cursor doesn't equal stood ranges end of the reader, and then we can basically just do that. Whatever we define the format as, we can start pulling the data out of here. So texture TLV too small. Okay, so I guess like what would you want? We're going to want a width, a height, a format, a usage, and then the data. It doesn't really matter like what order those are. So I'm just going to start building this out now. Height. So width, a height, a usage, a format, and a data. So format, usage, data. All right, and then we just change those uint32ds to be the right type. So we don't want that. Texture format, texture usage, and then dot byte array. Right, okay, and then once we've got all that, remove that last one, because actually, I guess to be super correct, oh my goodness, don't know what's happened here. Right, there we go. We want to check that we are actually at the end of the reader at that point, as in there isn't too much data, in which case that would be too large. Just help ourselves out as we go along. Text value, thank you. And this is super easy for us to build as well, because once we have a writer class, we can just write sub TLVs to just bung into all this data. And then we should be able to return a new texture. I guess the only issue with this is that it will, when you load it, it will construct, it will call all the OpenGL gubbins for you. So this will actually allocate this. The process of pulling this out of the TLV will cause graphics card allocations. It will cause OpenGL to do that. I think we just need to be aware that that is happening, because I think you're just going to dump all the textures to start with, and then we'll just pass them around by pointers anyway, or references or whatever. So I'm just trying to think if there's a situation where we wouldn't want that. I don't think so, because I think you would be pulling the data out and then constructing the texture data immediately anyway. Right? I think so. Anyway, sounds good to me. So then we can do usage, data, width, height, and then we'll add the format later. Because the reason we'll need to add the format later is because when we actually rework this, we will no longer need to use STB because we would have pre-packed all the data. In fact, the STB code is going to move over to a separate utility which will pass and pack everything for us. I guess the only thing we're missing now is I'm not convinced this is right, because now I can't... Where's the name? Would it make more sense to call size function length to make idiomatic type length value class name? Yes, it would. I'm kind of surprised I hadn't already done that. That's a good point. No, because this size returns the size of the whole thing. It's the size of the type plus the size of the... It's the size of the type, the length, and the value combined. So it's actually the full binary data required to represent this. Yeah, but yeah, okay, so fine, sure, we could put the name here, right? But then what I'm saying is, if I'm returning a texture, texture doesn't... Texture doesn't have the concept of a name. So if I want to search for a particular texture to load by name, right, which seems to be a thing you're going to want to do, where would that happen? Because I don't want to have to construct every single texture because it does an OpenGL call. What I'm thinking is I might actually have to have something like a texture data, right, which you can return, and from that we could then construct a texture from it, and then this would have a texture usage. Sorry, and then I don't have to worry about the pre-coding the format. And then stood vector stood byte. And then this would return that. Or the alternative is you just make texture have a name, so the texture knows its own name, and then when you are searching for it, I think the problem is, okay, it might be inevitable. Yeah, we've not. So the way I'm coding a lot of this, I'm only adding stuff I need rather than stuff like we think we need, and I've not needed a length function yet, so I've just not encoded it. I've just not coded it. So basically, we want to replace this, right? So at the moment, we have a resource loader and we load binary data, right? And then we give it a name. The resource loader will stay, but we will abstract away the raw source of the binary. At the moment, internally, it's reading from, it's just enumerating through files. So interesting problem. What's the best way to do this? Because the alternative is that, I guess I'm not too worried about efficiency, I'm more worried about convenience. I don't want, I think I don't want to have to construct an OpenGL object for everything in the data structure just to search for one, because imagine we have like 5 levels and each of them have 5 unique textures, and I'm loading the last level, I shouldn't have to construct every single object just to get there. However, I'm not too fussed about copying the data out, because it's unlikely we're going to be doing this on the fly. We should be able to, this should all be part of loading. It's going to be relatively quick anyway. I mean, I don't think we're that far away from making a game. I think we can start laying the foundations for a game literally in a few streams time. Once we've packed the resources, then we're going to do physics engine next. And then we've kind of got all the bits and pieces to start having a play around. Like, yeah, we're still far away from making a game, but I don't think we're too far. We've got windowing, we've got render pipelines, we've got HDR, we've got gamma correction, we've got normal mapping, we've got multi-lights, point lights. I think we've got quite a lot done already. No, I'm not planning on editing any of these videos down. They just go up as VODs on the channel. Unfortunately, I just do not have the bandwidth to be able to cut these down into videos. I think let's just continue. Let's do texture data. I think that's what I want. Because this isn't too bad actually, because this is just non-owning views. Anyway, there's no copying. We could use a range to filter down everything to just the texture datas, and then what we could do is we could have like a separate method which was like check like query texture name or something. This is already quite tightly coupled to these types, so I'm not opposed to having like a is named texture or something like that, and then we just read to the name field and return that. So that being said, do I then keep it as texture and just include the name? Actually, okay, fine. I'm thinking. Sorry, I'm kind of thinking about this on the fly. Let's do that. Let's get rid of texture data. Okay, let's go back to TLV entry. We'll keep that as a texture, but we can also do auto check. No, is texture. Just a string view name const bool, right? So we can call this first on our texture to query the name field, and then if we like it, we can just pull out the texture. Yeah, we're just adding as many as we need. Okay, fine. I think I like that. So let's put the name first, just because it's less I have to worry about. So what we'll do is we will do ensure star reader cursor dot type equals TLV entry. Nope, TLV type string first member not string, and then we'll just advance over it because we don't actually care about it for constructing the string. Expression result unused. What do you mean? Have I unbalanced my... Okay, right. Sorry, sometimes it takes me a while to kind of come up with a solution that I like. Auto TLV entry is texture stood string view name const bool. So now we can do we still need to check that the type is a texture because you don't want to be querying a name or something that's not texture, and we're still going to want to get the reader and actually the trying to wean myself off using the mouse so much, cursor, and then we want to ensure that we should const auto name equals reader cursor dot of course, sorry, it's an iterator dot string value. Okay. We get texture name, and then we can just return texture name equals name. Okay, so for searching for strings, for textures, then we can just do it by name. I hope that makes sense, right? So we've encoded a name in the texture, although we don't actually need it to construct a texture. However, we now have an additional method which basically says, is this the texture that we're looking for? I think that kind of gives us the flexibility we want. Ensure is just something that I wrote. It checks predicate and then throws an exception if it fails, but it has some fancy formatting, which actually I keep meaning to improve, but I've just not gotten around to do it. I think we can use some more template magic to remove the need for V format, but here we are. Okay. We should probably test this. C2t underscore texture valid, and then okay. So we're gonna need to create our own. We're gonna ham roll some bytes again. What is that? Random extra character. Okay. Yeah, I was thinking that maybe I should just write the writer, but then it's one of those things where I feel like should we just write the writer? Yeah, okay, because I think this is gonna be a nightmare. Let's do that. Let's undo this. Take a brief pause, and we will go and write the writer. Where did I get to? Oh my goodness, I got myself so confused. All right. I'm glad it's decided to rebuild everything. I guess I must have changed a header. Where have I gone wrong? Resolved. Unresolved external simple GL delete textures referenced in. Where's that referencing it from? Texture CPP. Here we go. In what? It's a new one. I've definitely included OpenGL. I've definitely got my delete textures. Why is that? But it's when linking unit tests. So why is unit tests not finding? Because there should be no linking. There's no linking to OpenGL because we resolve all the functions ourselves, right? Right? We got our texture in the game lib, and then we link our game lib to the unit tests. But there is no linking to OpenGL because we resolve all the functions ourselves, which is kind of what we're missing. Why does it work for the main executable? Look, our game, but also everything's in the game lib, which is all public, so this should pick up on it anyway. Which also technically means I think we don't need these. Let's just do a... Yes, thanks Julian for answering that. How bizarre. Why? Oh, actually, maybe we... Oh, Christ, it's getting worse. Okay, fine. Maybe I do need those files. I bet I need to target link one because it's in a different directory. Do we actually... I lie. Maybe we do link again. Please stop. Please stop. Maybe we... In window, do we use the weird... Yeah, got the weird window compile time linker line. I bet that's it. I lied, sorry. for whoever said we're not linking against OpenGL, and I was like, we're doing it all at runtime. We still need to link against the default Microsoft implementation, even though it's only like GL 1.2. Okay, fine. That was a fun detour. Writer. Okay, fine. So source TLV writer.cpp. Nope. .h. Let's get the entry up because that's what we're going to want to be doing. Building. Okay. Pragma1s. Namespace. Game. Class TLV. TLV writer. We'll have some publics and we'll have some privates. We will have also a vector. We'll have also a.
I'm not quite sure how to help you with that.
The Alexa's talking to me again. Used to def. We'll also have a string, and I imagine we'll also probably end up needing a string view. And probably a span as well, but let's not get too ahead of ourselves. Oh, we will need a cstudent. Okay, right, that's brought a lot of stuff in. NVim is the same as NeoVim. They're just different. Like the NVim is the name of the executable. Yeah, it's just a standard workflow. It's just a normal workflow. Okay, so stud vector stud byte buffer. I like to have a yield method. What that basically does is it will return this vector, but it will clear it at the same time. So the idea is that you kind of use your writer, you write out your structure, you yield out, you literally return the copy of the buffer, and then you can keep writing the next one as well. Arguably, semantically, you should probably use a separate writer per thing, but I think that actually, it might make the code a little bit easier. And I think it's kind of more obvious that you're effectively becoming the sole owner of the buffer that you've written because you'll yield it out. When do you use fixed size primitive types? I'm never sure should use uint32 everywhere or if that's being pedantic unless it's absolutely necessary. So this is a really good question. I would say that you're always better off using the fixed width integer types because you are explicit about the sized and the signedness. There is no arguments. You know exactly how many bits and whether it's signed or unsigned. It's absolutely crucial to use that if you are writing cross-platform code because a long is a different size on Windows and on POSIX. So if you just encode everything as a long and you can, and you sort of send it over the wire from one to the other and you reinterpret cast or memcopy it or whatever, they will be different sizes. So if you use the fixed width integer types, there's literally no arguments. I would say be pragmatic though, like an int in a for loop when you're going to loop 10 times or something is absolutely fine, but for me I would always prefer to just write out the fixed width integer types and then it's super explicit. I mean, normally I just use auto anyway, but yeah, that's kind of my view on that. Yes, I have come across this before, and the only reason I know this is because I've made this mistake before of using long when I was just sort of starting out programming, and I was like, oh, this is terrible, I should not use this. Another fun one is which-rt is a different size on Windows and on Linux. So if you use wide strings on Windows and try and serialize them and send them over to Linux or vice versa, you're gonna have a bad time. Yeah, I mean, long is a standard type in the language, but Microsoft makes it angry by making it all uppercase. Okay, so we're basically just going to want a bunch of write things, right? So std uint32t value void just use the string view and then include spam auto write std span const std byte value auto write g hash include, bring the old texture, and then texture format value auto write texture usage value, and then finally auto write. So for texture, we're going to want to take everything we said. So that will be a std string view name, std uint32t width, std uint32t height, a texture format, the texture usage, std span const std byte data, which is a little gross. Yes, I saw your email pop up earlier. I've just not had a chance to read it yet. Sorry. I will try and get to it later. Is it possible to pause and resume a thread after in standard C++? No, the standard C++ threading API does not give you that level of control. However, what you can do is, excuse me, 1 second, acceptable. Instead thread, and the same for JThread as well, there should be a native handle. This returns a native handle type. On Linux, this will be a POSIX thread handle. On Windows, this will be a thread handle, and then you can then use the specific platform API that you have to do those things, because pausing a thread, so on Windows, for instance, you can do suspend thread. So this handle here will be the result of your native handle type in Windows, but you'll be straying into non platform specific code, so it won't be cross platform. That's what I'm looking for. But yeah, it's possible, but you kind of have to bust out of the quote unquote safety of C++. Anyway, right, we now need to write all these methods. I guess the advantage of using yield is I can do this. Sorry, the advantage of using auto is that I can then do this. QA, NA, QJ, Oh, hang on, what have I done? My macro exploded out from underneath me then. Okay. And then we can do things like auto temp equal. Grab all my includes a second. Hold on one moment. Okay, and then we do temp equals stood move buffer. So here's an interesting question for you. Is this undefined behavior to then use this buffer afterwards? So I've transferred ownership of the contents of buffer to temp, and I've returned it. This effectively yields, I would argue, this yields out the array, the vector. But can you then use buffer again after this? So I believe the standard says that this is left in a valid but unknown state. So I think it would be undefined. So I think for the sake of completeness, we'll just reconstruct it there. I think that's right. Yes, actually, that is. Yes, you're right. That is actually easier. Sorry, I caught up my own little world there of talking about undefined behavior when it's actually a better way of doing it. Good suggestion. I like it. There you go. Nice. Okay. I need to get this compiling so I can fix my tooling, so I can actually write some of this, because all these errors are doing my head in. So this won't build at the moment. Okay. We need to put the last one in, but let's just get this building first, because we're not going to be using that one anyway. And it's okay to not implement a member as long as we don't use it. Okay, cmake source. Someone already spotted the issue. Thank you. Excuse me. What does the implementation of the vector move constructor look like? I mean, it is down to the implementation, but I would say most common implementations of vector use 3 pointers, one for the start of the range, one for the end, and then one for the capacity. And so the move constructor will literally just copy those 3 vectors over. So that's why it's faster than copying everything, because all you're doing is just moving the pointers, the bookkeeping bit, to the next one. It's kind of like the poster child for move semantics is vector, because it's much, much more efficient to, assuming your data is less than whatever the cost it is to copy 3 pointers, then yeah, moving is faster. I use. Do I use LazyVim? Oh no, I used Kickstart for my MVim setup. Okay. Let's start implementing this. Okay, cool. So we need to 550 followers on Twitch. Exciting. Thank you very much. Whoever was the last one to push me over. Much appreciated. Again, the standard just says that it has to be left in a valid but unknown state. And I believe valid means you can reassign to it and you can destruct it. And you might possibly be able to call empty on it. I'm not even sure if that is well defined. So yeah, all those pointers could effectively be null. It's still it's a valid object because you can destruct it and you can reassign something to it, but the state is unknown. Is it safe to do context switching user space in an interrupt handler? You have to be really careful what you do in an interrupt handler, and I can't remember the specific rules, so I wouldn't like to say for sure. Yeah, I wouldn't like to say for sure. You'd have to check the man pages. Hopefully, can give you some advice on that. Although it sounds like you're doing something a little bit exotic anyway. Okay, so we've got our buffer, and we need to write data into it. So we need to auto write bytes std vector std byte buffer std span const std byte data. So I think this is going to be what buffer dot insert std ranges end buffer std. I don't think there's a ranges for inserting data. C begin data std ranges C end data. I think that's right. That will insert data at the end of the buffer. So we're basically just going to cast everything to a span of bytes and then just use this to stick it in there. Because it is well defined to reinterpret cast something as a byte array, because that is how you do that is literally how you do serialization. So let's do const auto type equals TLV type uint const auto size equal. In fact, actually, we might end up pulling this out into a helper function anyway. Const auto size equals size of value in this case. Let's keep it consistent. Const auto value equals std span const std byte of reinterpret cast std uint32t value length. Value bytes. That was not the one I wanted to close. Oh, that's not going to work for me, is it? Constant byte star. Okay. Is that right? So we've got the type, the length, and the value bytes. So now I should just be able to do write bytes. Okay, and now I think what I want to do is do auto write entry and have a game TLB type a stud unit32t length, then a stud span const. Maybe one day we'll alias this, but today is not that day. Value a void and then we're going to do write stud vector stud byte buffer write bytes buffer reinterpret cast constant byte star the type size of type. This will be the, this is encoding the type, and then we want to encode the length. Note we don't pass in the length as the size of the length, if that makes sense, because we only take 4 bytes to serialize the length, and then write bytes buffer value. So that should give us our 3 component entry for everything: the type, the length, and the value. So now we should just be able to do write entry buffer type length, right? Value bytes, right? God, we've only been streaming for an hour and a half and I'm still only doing the right. This might spill over into a third stream. I do apologise, but hopefully this is interesting to people. We need to do it, and I said I wanted to do everything for this game live, so if we have to take a couple of streams to do this, we do. But physics soon. Well, attempt at physics soon. Oh, Capsule, you subscribed with Prime. Thank you very much. I didn't see that. Apologies. It's taking this long to get around to it. Much appreciated. Thank you. Sorry, I've just I've seen your message. How would you perform context switching? I think what you're trying to achieve is effectively fibers, right? You want runtime, kind of like runtime threads, effectively. You might be able to get away with C++ coroutines because they are similar but not totally the same. Or you could just use, if you like, could just use boost fibers, right? I think this is probably what you want. Micro userland threads scheduled cooperatively. I think this is probably what you want. So if you are, and it's even got the implementation, it implements using new context T or WinFibers or fcontext T. So Boost is all open source. So I would suggest you kind of look at their It's never easy, but you could look at the boost implementation to get an idea of it. I wouldn't be able to give you any more information than that, I'm afraid. I have written my own fiber implementation before, and you have to write your own custom assembly because you have to do weird stuff with switching like the stacks around, and it's a massive pain, and it never worked. But yeah, if you're happy to use something off the shelf, I think Boost Fiber will probably get you most of the way you want to go. All right, tests. Let's go hash include TLV writer. Put these at the bottom. Hello. And then this will be right unit 32. Oh, hang on, I've accidentally the brackets. Oh yeah, right. Yeah, no worries. I'm glad it helped. So when it comes to writing tests, I'm a big fan of, if you've already tested it, then you can kind of reuse it, if that makes sense. So we've already tested the reading the Win32 code, so I'm kind of okay to reuse it in the test here. So let's do auto value equals, because basically there's kind of two ways we could do this. We could write a load of stuff and then read out the raw bytes and then check those bytes, but then that's kind of the same issue we've got before where we're just hard coding all these bytes, whereas we've kind of done a lot of the legwork on the primitive types already. So we could just take that writer, bung it into the reader, and check the right value comes out, and that kind of round trips the whole thing. So I think that's kind of what I want to do. OX AABB CCBD. Okay. So then we're going to do game TLV writer. No, we're not. We're going to do auto writer. That's another thing I'm trying out in this project, is basically always, where possible, where the language allows me, always starting with auto something equals something, just for consistency. I quite like that. I must admit, I would probably keep that up. Training return type, I kind of like it. Actually, on the trading return type, which is the sort of perpetual topic of conversation in these streams, I was writing some code for what's hopefully going to be the next YouTube video, and I found myself writing auto something arrow. So maybe I do like it. So arrange act writer dot write value assert auto reader. Nope, that's not. Reader equals gain TLV reader writer dot. Oh, that's going to create a temporary, isn't it? Would it extend the lifetime of it? Let's not worry about it. Let's just literally not even worry about it. Const auto buffer equals writer dot yield. Why is that not? And then we can do pass that into the buffer, and then we can do assert equals value reader dot uint32 value. Okay, so basically we create our value, create a writer, we bung it into the writer, which in theory should encode the type and the length and all that other governs. We then pull out the buffer, we then stick that into the reader, and then we pull it out by the reader, which will validate for us, because it'll throw otherwise the type and the length are correct, and then we'll get the value out, and then we will check that. So Sound good? Not to the compiler. You went 32. Not a value of read. Oh, right. One day I'll remember how I've coded this. Const auto entry equals stirred ranges begin reader. Just do it like the standard does, he said. It'll be nice, he said. Yeah, I think, like, I wonder what I care more about when I'm reading a function. Probably the name and the arguments, and then actually the return type. Like, if I'm passing left to right, I actually probably don't care about the return type till I've had a thought about what the function name is and its inputs. Hey, you're right. I can't. You know what, compiler? I'll give you that one. You're right. I can't dereference the reader. Nice, nailed it. Okay, right. Well, now you got to watch me fill in the. We've done the fun bit, right? One. Now you got to watch me fill in the blanks for all the others. Okay, so uint string. Absolutely not. So the length now is value.length, right? And that will be without any null, without a terminated null character, because the string view doesn't guarantee it anyway, so we're absolutely cool with that. And then the byte value will be value.data. That should be it. Yeah, no worries. Thanks for that. Okay, we're getting there. So for the length of the value is size. Size and size bytes are equivalent in this because we're only storing bytes, and that should all stay the same because value.data. So value std span has a .data method, and same as string view, and they're conceptually the same thing. Although I do absolutely not want it to be a string. I want that to be a byte array. And then 68G. Okay, getting there. I don't think I could actually simplify this anymore. I think this is literally just a case of repeating all this. Back to the. Oh, hang on. Steady. Okay, and then we get to do the interesting one, which is texture. Oh my goodness! Sometimes with Vim, just you press the wrong thing and it absolutely explodes from under your feet. What is going on? That's what I wanted. df space, get rid of that. Oh my goodness. Ooh. Right, DF space. The problem is on this new keyboard, the shape. I don't know what's different to my previous one, but I keep hitting the tab key when I meant to hit the caps lock key. I mean, it's ultimately a me problem, but okay, let's round trip all those super quick. I'm not too. I'm not too fussed about the enums. I'm pretty sure they're going to work. We can do this later. I think the main ones are the string and the byte array because they are actually interesting. I don't even. Oh yeah, I do need that. These could also probably be parameterized as well, but what you're gonna do? And this will be byte array. We've got byte array we used before, because I just really cannot bothered. Right, bytes. It'd be interesting to see if this picks it up, because I think it should, because it should implicitly cast to a span, and I don't think it won't match anything else. So I think that should be fine. This is going to work first time. Nope. Ooh, interesting. What have I done wrong? On the writer 57. Ready? '57 and 65. One of those. Ah, yes, of course. Thank you. Thanks, MSVC. You are right. I don't. It's a little bit pedantic, but I did ask you to be, so I can't really fault you for doing actually what I asked you to. Perhaps if I write that right. Yeah, cast. So basically, I guess rather than me, I try not just sort of like charge off and do too much typing without explaining what I'm doing. Size and length as defined by the standard will return a size t on a 64-bit platform. That will be equivalent of uint 64t. I've said in write entry I want a uint 32t, which is half the size, and the compiler, I've told the compiler to issue a warnings, and it is a warning when you truncate a size, because you could potentially lose data when you go from a larger size to a smaller size. So it shouldn't implicitly do that for you, which is why I have to step in and say no. I'm okay with accepting the consequences of this. It's unlikely I'm going to have a string that's uint 32t max size or larger, so I'm kind of okay with just slicing those last bytes off. Cool. Oh, I'm glad you found us. I won't repeat your name on stream, but Mr. Source, I'm glad you found us, or Mrs. Source even. Although statistically, looking at my analytics, my demographic is skewed more towards one gender than the other. But yeah, it's somewhat irrelevant. Makes no odds to me. Okay, right. So now I think we can do the texture, which is actually the interesting one. Oh god, everything just exploded then out from underneath me. Okay. So the value for this is actually going to be another TLV writer. So we'll do an auto writer TLV writer first. Yes, yeah. I agree. All good comments there from both Twitch and chat about Twitch and YouTube about we're probably not going to have a 4 gig plus texture, and if we do, something has gone wrong. Okay, so now what I need to do is actually here we need to be careful because we need to make sure that the entry, we are sticking them in the same order here. So I believe the order is name, width, height, format, usage, data. So we'll do writer.write name. I'm hoping format. They should all be in the order of the arguments. They are. Width, height, format. I think I'm one short. Usage, data. So now what we can do is we can basically take this code here and our type is a texture. Our const auto value equals writer.yield. Okay, and then our length is value.size. I'm going to head this off at the pass and just static cast it now. I'm glad so this is kind of the point, right? I'm kind of, it's good that people find some interest in things I say. I sort of vomit loads of words into YouTube videos and to live streams, and I hope that someone somewhere finds some of it interesting or useful. Okay, so the value bytes is going to be wrong because this needs to be, in fact, actually, because it's already a vector. Oh, steady on. I think we can just do this, which is not bad. Like using a sub TLV for aggregate types actually makes things really nice because then we can just reuse all the stuff we've done. We just have to have a bunch of primitives, and then as long as we can represent something in those primitives or add more if needed, we get hopefully something quite nice. So now, moment of truth. If this works, then basically, we will see if we can encode a texture and then get the game to load it, which will be, I think, a nice way to kind of wrap it all up. If it doesn't work, then we'll fix it and then we'll try and do that. And then next stream, we'll build out the actual pipeline bit. So we'll write a new program, which will take all the resources, pack it into one massive TLV, make that available to the game. The game will then abstract away the resource loader to have different resource sources. So it might be from the file system, it might be from a TLV. We'll put all that behind an interface, and then we'll have the game be able to consume all that. So that should draw a nice line under it, and then we'll be kind of ready to tackle something more graphicsy. Do I prefer Windows or Linux for development? I prefer Linux on Windows. I don't actually care. I'm pretty used to a Windows environment. Like, you know, my home machine is Windows, but I prefer Linux for a dev environment. I prefer, like, I find just NeoVim works much better. I just absolutely just cannot get by without Tmux. I prefer the command line tools. So yeah. That's why I kind of have this weird setup. Okay, let's do right. Let's write texture. We're just going to write some random stuff to this. We're going to do, it's not going to be a valid texture, but it's just going to be, you know, like it's not going to represent valid ping, for example. It's just an example. I always like in situations like this. I always like to try and make these different values, just on the odd chance we had a bug where we accidentally copied the width into the heights. Like I want to make sure we check those separately. It's auto format equals game texture format RGB. Sure, why not? Const auto usage equals game texture usage. Let's pick something that's not the first one. Let's do sRGB. And then we've got the data there. Three pixels for our 100 by 101 image. I don't work in the games industry. I never have. I have no idea if this is common or not. This is just a serialization method that I know and I wanted to use. I also find that the documentation, there's like Wikipedia doesn't have a particularly good article on this. I always find that there's not loads out there, so I kind of thought it might be interesting to kind of go through it. Usage. There you go. So we're going to write our name, width, height, format, usage, data. Hopefully that matches all the arguments. Get the buffer out, and then we will do const auto texture. So testing this is going to be a pain because it's going to try and create an OpenGL object, which it might not be able to do. Because all my code's gone. This was the thing I was talking about at the beginning of the stream. If you call the constructor, I mean, none of this is going to work anyway, actually, because we've got all this gubbins in here which we need to get rid of. Yeah, it's going to try and create this and upload it, which maybe we do need a texture data. Maybe we need a layer of abstraction between constructing the OpenGL texture and just getting the texture data. Yeah, but I want correct by construction. I want, if I create a texture object, like that should be ready to go in an OpenGL context, right? That we should be good to go. I don't like the idea that you have to create the texture object then call like init, or two-phase construction is just a pain. So I think the abstraction should actually become before texture. So we keep the same pre and post conditions and the same API for texture, but we basically take all this data and we bung it into a struct, and then that's the struct that we can construct. Optional bool load. That really feels like a hack. That. Also, that's not going to. That's not. Oh my goodness! I didn't even know I had that installed. Oh, can you go away? Because none of this data is currently exposed by it. We don't, like, this is just a really light wrapper around the OpenGL context at the moment. I mean, eventually we probably will need to expose the width and height, and I'm not opposed to adding code just for testing, but I still think this is the wrong solution. I think we're just going to do it struct something like like raw texture data, or maybe texture description. So here's how I would describe a texture I want, and then it's the class's responsibility to reify that in whatever it makes sense for OpenGL. So that's going to be stood unit 32t width stood unit 32t height texture format texture usage and then stood. It's going to be quite heavy object, this. Byte data. We might be able to improve that in the future and make that a span if we can guarantee somewhere else will own the data, but for now I think that's fine. Yeah, no, this is stream 14 or 15. We'll get up what we've got later, the actual game. We've got loads of stuff, like we've got loads of like 3D rendering stuff going on. Do I want to include the name in there? I'm not for no at the moment because texture doesn't care about it, and this is just designed to serve this. So at the moment I'm going to keep name out. I reserve the right to be wrong and to fix that and to change it in the future. Stream 18, Christ, I've been doing this for a while. 2 hour, I stream 2 to 3 hours Wednesdays and Sundays. What is it not like about this? Oh, because because I'm thinking of spans, that's why. Oh, so many C++ concepts. So much going on. Right, okay, so now, super quick, change all of our interfaces. TLB entry, it's literally there. From texture to texture. I prefer this. I didn't like the idea that what popped out of the TLV was a fully formed OpenGL context, like a fully formed OpenGL object. So I'm actually, whilst it is a little bit more work now, I'm actually happier with that as a concept. What are you not liking about that? Oh, probably the semicolon on the end. So that should all work. Usage, width, height, format, usage, stood, move, data, and then we'll make that non-const. Transfer ownership of that. Transfer ownership of this into the new struct. Yeah, I think structs are like, I mean, struct, like, it's part of the language, right? You should use, in my mind, conceptually, I use structs for bundles of data where I want them both all to be mutable and to, well, I don't have any methods on it. That's kind of how I use structs. It's just like packages of data, and classes tend to be, you know, conceptually for me, the thing with the methods on it in the private, you know, data and stuff like that. Obviously, you don't have to do that. That's just for me conceptually how I kind of think of it. Yes, apologies if you're not. Yeah, my plan for this is to basically use all the bleeding edge features. So as soon as MSVC supports it, I'll be using it. Okay, so now our writer is going to be unhappy. In fact, actually, our aggregate type is no longer correct, isn't it? So this should be texture descriptor or description. Description. Our entry is also going to be wrong. Okay, I think that's enough, maybe, possibly even for us to test this. So write texture description. And now auto texture desc equals entry dot texture description value, and now assert equals name texture desktop name width height format usage data. No, the name won't be in there, but we will check the name with the other method that we used earlier. So that's width, height, format, usage, data. Yeah, this is still the game of the lights with the array of boxes. I'm just building out some of the tooling around what we're going to need for the game. So like the asset pipeline, illegal qualifier. Also, Oh yeah. I mean, you should unit test what you can. I think it's hard to unit test graphic stuff just because, just the nature of it. Where have we gone wrong? Yeah, I mean, this is purely like shuffling bytes around, so it's very easy to unit test, and it actually helps us develop it because I can use, like now, I can use the tests to drive it. Incorrect type thrown in test body. Interesting. Right, let's debug this. It must be this, because this is the only... No, not at all actually. We could have put the objects in the wrong order. Let's just verify this. So we codify the type, which is a texture description, with the length, which is our data, and then the data itself. So that is probably legit. We then do... Oh, do I have to put the name in there? Oh, no, of course I'm going to have to put the name in there. Because... Am I? I'm doubting myself now. No, I still need to encode the name. I just don't have to copy it out to the final object. Let's look at... entry. Yes, because we skip over the name. So we go name, string, width, uint32, uint32, height, uint32, uint32, format, usage, data. It'd be really useful if the exception told me, can I get gtest to print out the exception information? Oh, do I need to use... Oh, actually, I can just print out E, can't I? I've already got a formatter for it. And then just rethrow that afterwards. Ugh, right, well, at least we've got full stack trace, that's nice. Nope, I just didn't compile. I thought that was my stack trace. It just got some miserable code. Oh, of course, I can't just take that variable off, can I? Just do that there. What's the most pain-inducing, complicated project job you've ever had to work on my career? I don't know. It's hard because I'm constantly looking for new challenges. You're kind of always trying to keep at that threshold anyway. So everything's a, I'm always looking for new challenges and stuff. So I'd have to think about it. I can't think of anything off the top of my head. How do we fix that? Can anyone remember how we fixed the symbols being missing from the stack trace? It should bring those flags with it, right? Because they're public, but oh, hang on, no, I know why. I bet it'll work now, and not because of that. Yeah, I just realised I rebooted my machine and the Z drive had been unmapped. I literally just mounted it then, and it worked. Okay. TLV entry line 70. Thank you, stack trace. Can't believe it's taken C++ this long to get this. I don't know how we survived without it before it. Texture usage, hey? Interesting. I bet I know. I bet I've copied the yeah, there it is. There's the badger. Copy and paste error. I knew I should have tested all those individually. I was like, nah, they'll be fine. They'll be fine. I was like, they'll be fine. Unbelievable. That's unbelievable. Shouldn't let me write code. Oh, look at that. Serialize a texture. Okay, let's super quick try and merge all this together into something horrific that might just work. Okay, right. What I'm going to do is I'm going to abuse this test because I don't really want to go through all the faff of writing the extra program now. I want to, blimey. I want to do all that, like start one stream, we'll write out the next program, the packager, build it all out, build it into CMake. I think that is a whole separate stream, that. So what I will do is oh, thank you, Luke, for the super chat, much appreciated. Is C++ definitely the language to learn for game hacking? Couldn't we use C, Zig, or Rust? It doesn't actually matter, because if you're just writing tooling for it, then any of those low-level languages will do the trick, as long as they have access to like the native APIs. You've got access to Win32 or the POSIX. I don't think it matters. So the correct one will be whichever one you are kind of probably most comfortable with in order to achieve the goal. So for me, it's C++, because I don't know Zig and I know C, but not as well as I know C++. Obviously, if you're kind of looking at disassembler output, like decompilers will make it look like C code, like terrible C code. So, I think. So, AC says Lua. I think the question is probably more around like, if you need to interact with the Win32 API. So like early on when we need to call that suspend thread. I mean, I'm sure all languages have native binding, so actually probably maybe even doesn't matter. I do think there's a certain mentality of keeping it kind of the tooling you write kind of close to the metal, because it might be easier to interrupt with and kind of conceptually understand what's going on. I don't know. That's kind of my view on it. Again, the right tool is the one that you kind of know and helps you get the job done. That's arguably is the sort of the politician's answer for it. I mean, I did do a video on a C# game, and I did use C++ because, again, I wanted to use the Win32 API to interact with it. You know, enumerate the threads, search through the memory. Doesn't mean I couldn't have done that in C#. Probably could have, but again, it's the language I know. Stirred OF. File dot right. Is that to be honest, so rarely I do file IO in C++. Oh no, I only went to c++.com then. That would have been a mistake. It is of a char type, so why is it not like my char type? Oh. That'd be a function. Size is a function. Oh, bleh. Yeah, and then I think the reason to not use a language you're familiar in is if you're trying to learn that and you're thinking that might be a good example, you know, a good way of, you know, a good opportunity to learn it. But yeah, I would agree. Just right tool for the right job, and quite often the right tool is one you know, but not always. So, you know, if all you have is a hammer, everything looks a nail, all that kind of thing. Did it produce a file? It was kind of expecting that to write out a file. Should produce it from the current working directory. Okay, fine. Put it in there. So here we can see our TLV, type, length, and then inside that we have the type 1, which is the string, length is the 7, then the string data, and then the next thing. So it's kind of nice, you can kind of see, I mean, we know it all works because it's there, but we can see it. That's actually not going to work for us, is it? I've just realised that. I need to... I need to actually use a real texture, don't I? So auto in file equals stirred if stream. Where did this go? In the test directory. So up to the build, up to the project root, assets. I can't remember what it's called now. This was going from the tests up to here. Assets. Vowels from albedo. Did I get that? I did, right. This is not how you should write code, by the way. Okay. Cert true in file. Right, okay. Super quickly read in this file. Oh. Auto string equals string in file.rd buff const auto data is a str equals string.str. Okay. Yeah, sorry, this is gtest. Okay. So, because we haven't rewritten any ranges yet, it'd be rude not to. Const auto data equals data struct std views transform auto b return static. Oh my goodness. Std byte b, close that, std ranges to std vector. Okay. So this just reads in the data as binary data, reads it into a string, because as far as I can tell, that's kind of really the best way of doing it, and then it just converts this into a vector of bytes. So kind of copying it around a bit, but I don't really care. And then I will... What am I doing? We should have a lot of this here already, so we should know, here we go, the size of it. So it's 4096, 4096. So let's write out, let's do auto writer equals game TLV writer. And then writer dot write. Oh, we need to test the other writer method, the one that allows us to just get the string out, but that's fine for the moment. I'll give it a sensible name, and then what were the things we wanted? The width, that's 4096U. 4096U. Format will be game text format RGBA. Yeah, I think game texture usage sRGB because it's not data, and then the data itself. And then all my code disappeared. Okay, so we got that, got that, and then we can do const auto buffer equals writer dot yield. And then that should write all that. Yeah, so the idea of the pipeline is that we want to, at the moment when we load all our resources, it's quite slow because we're passing every time and we're using a kind of a slow library. I want to offload all that to an offload process. So we just produce a binary format that the game kind of internally understands very well. And should be much faster. And it's a bit of fun as well. Like we've done a lot of graphics programming and I wanted to get back to do a bit more just like C++ programming, I guess. Is it not RD buff? RD buff. Okay, right. Oh, taking a little bit longer this. Okay. XXD tests resource. Whoa. Okay, that certainly looks like a lot of texture data in there. Let's just yeah, got all the names and the stuff in there. There's the ping header. Okay, so now main. Let's do R3 and we'll pass into this our, actually no, what we can do is we can kind of use the, if we stick it in the resource directory, we can just load it out as normal because we'll just reuse all the code we've already written. So TLV reader, this is at the end of every stream, there's always like a mad dash to try and get something actually, like kind of bring it all together into something useful. So const auto TLV buffer equals resource loader dot load binary resource const auto text desk equals TLV, nope, const auto reader equals game TLV reader TLV buffer const auto entry equals stirred ranges begin reader const auto text desk equals entry dot text description value. Nailed it. Okay, so now all we got to do is add a super quick add another constructor which just takes in a const auto texture description. I'm gonna. What am I doing? Ugh. Yeah. No. Sorry. I was off on my own little world then. Okay. What I'm going to do is do what I would always advise you don't do, and I'm just going to massively copy this code here, and then we'll tidy it up. This whole texture code needs tidying up, so we'll tidy it up in a future stream. I just want to kind of check this works. So what's that? 50. Ooh. 53G. Down. Okay, right. So that's all the same. That's all the same. We don't have to worry about any of this because we've got it all. 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 So we can create the texture. We've got all this. We will need to convert them. So the auto. Let's just ensure description dot format equals texture format RGB. Please implement the rest. Usage. Texture usage sRGB, and now I can just happily hard code all of these as as GL S RGBA alpha 8. Description dot H description dot, and then fh dot steady. Okay, fine. You've description. Oh my goodness, what is going on? Description dot FNC, and then this will just be raw data would now becomes description dot data. Oh, we've got data again. I love it. Okay. Pipe character is the pipe operator. Sorry, the pipe. Operator is in a binary operator, and it has what can take two things. Is overloadable in C++. So you can choose to have your class accept the or overload, and then call effectively a special function that you define for when you do it with your types. And ranges overloads that, so you can effectively pipe range operators together, much like you can on the Unix command line. That's kind of the theory behind it. Sorry, super quick overview on that. I've just seen there's a load of questions as I was madly typing away some terrible C++. Yeah, my fingers are all over the place there. I don't know what's going on. Yeah, ensures my own thing. It's it just takes a predicate and then throws an exception if it didn't like it. Well, I say it's not opinionated. If it was wrong. Okay. In fact, actually, to be honest, copying and pasting that's not too bad. Okay, right. So now, copy tests resource up into assets. Main. So I should be able to, in theory, replace this whole. I should be able to do. Oh, I've not got my auto thing here. That's oh, I've missed out loads of. What am I doing? I need to go and make all this consistent because I've messed up here. But let's do auto albedo text equals game texture text desk. Yeah, I nicked ensure from, is it GLSL, the Microsoft's implementation of the coding standards. They've got a few niceties in there. I really like ensure. Like, you know, this must work. They also have expect, which is like an assert, like I expect this to work, but you know, you can remove me at runtime. Whereas Ensure's like, no, it's always there. Right, I'm gonna do a poll. Let's do it. How do I do a poll with my new fancy setup? Right, hang on. Start a poll. Do we think this is just going to work and it'll load the tech, it will take the texture out of the TLV, stick it into OpenGL, it'll be cut and it will just render everything. I think start prediction, work first time. How we like to do things here. Predicting on Twitch, there's a prediction. On YouTube, there is a poll. How confident are you in me? 100% no. On Twitch, like it. 50%, 50-50 on YouTube. So YouTube slightly more optimistic. Oh, it's split. Okay. Oh, it's going to change. Right. Locked in. Let's lock this in. And by working, I mean if there's compile errors, that doesn't count. Like when we eventually get to build, will it just work? Interesting. I didn't know that counted as gambling. Does it actually take real money? I thought it was just like fake internet currency that you put onto it. I'm not that in. I'm learning more about Twitch as time goes on. Oh, it crashed. Channel points, yeah. Oh well, I'm afraid the answer is no then, because it straight up just crashed. Why did it? I didn't even get any output. Like, let me just check we're actually running this correctly. If I give it another argument, does I? So that works. So it gets past there. It's gonna. I might need to make Nightbot a little less aggressive on the emotes. It's just the default settings. It's just the default settings. I need to have a look. Okay, so where did we get to? I suppose I could. Give me a second. Let's see if I can set up some sort of tooling to help with this. What's oh, bear with me one moment. I'm trying to get a debugger set up. Okay, we've crashed. Okay. Okay, well, I mean, that's because it's trying to copy RCX into XMO, and RCX isn't a real address, so that'd be why. But I mean, source I find it very hard to believe it's crashed there when we know it's getting to at least here. Can I set a breakpoint on here? I mean, that just crashed the debugger. So, I don't really know what to tell you. Fine, we'll do it the old-fashioned way. I will have to, unfortunately, take away your internet points if you voted wrong. Okay. So it's got to be somewhere in here. I'm not going to install another debugger now. What I need to do is add a formatter for this so we can see what comes out of it. Do I want where have we added a formatter? Matrix vector will have one, won't it? Game texture description. Okay, let's just do what we got. Width equals, height equals, format equals, usage equals, data equals, and then we'll do obj.width, obj.height, stood to underlying. Yes, I know we need to add formatters for the enums. I just want to kind of get us going. Format stood to underlying obj usage and data dot size. Hang on. Obj dot data. Hitting the tab key again. Right, okay, that should be enough to get us going. So let's go back to the texture and then print. And we should be able to like something like stood print ln creating text with description. Okay, sorry, quick detour there. You might be happy that you got the 3 points, but I'm sad that you thought it wasn't going to work. I mean, you were right, but okay. So creating texture with, it's got all the. Am I just driving OpenGL wrong? Yeah, print is so much better. It's also, I think, a bit better overriding for custom types as well. It's still a lot of boilerplate, but I think I prefer it to overriding the left bit, the left shift operator for an O stream. Handle 1, format, sRGB alpha 8, width, height, handle 000, width, height, RGBA. I'm very confused. I have no idea why this would crash. Like, if we got an OpenGL error, we would get an exception. Yeah. Unless. One of it's kind of sad that the debugger crashed. Right, there's no hiding now. We will, after this, we will know the offending line. No, I know exactly what's wrong. I know exactly what's wrong. We've not encoded RGBA tuples into the binary data. We've just slapped a ping in there, so it still needs decoding. Like, you can't just slap a ping in there and hope it's all going to work out. So I do actually need to copy this data here just for the moment, and then eventually it won't be a ping. I even said when we were looking at the binary data, oh look, you can see the ping header. That's wrong. You should just, when we write our actual program, we'll get rid of all that. So right, now I'm feeling confident. What a fool. Now it's got to load all the other things, and this is the problem. The startup time is incredibly long. Look, it's passing all the materials, all the models. There we go. Now we're cooking. Reinterpret cast versus static cast. When to use what? So, great question. Static. I'm going to go with partly my opinion, partly with like the mechanics of both of them. Static cast is the one you should always go for first. It checks that there is a valid cast within the language, i.e., the language knows how to actually convert from one type to the other. But that also includes user casts as well. So this, I assume there's one in here. So this says convert this, whatever size this type is, so it'll be a size T, a 64-bit integer, to a signed 32-bit integer. So static cast will almost certainly, or could, emit code right? It will actually cause a conversion function to be called, or a move sign extend, or zero extend, or whatever's needed. So and static cast checks, like I said, it checks that there is the language knows how to do the conversion, either from an inbuilt one or from a user-defined conversion. Reinterpret cast just says to the compiler, this type is now this type. It doesn't emit any code, it just changes the type. You can only do it on pointers and references. It basically says, you're pointing to an int, now you're pointing to a float. Reinterpret cast is riddled with undefined behavior. It is really hard to get right. In fact, this is wrong. This is undefined behavior because I'm getting a pointer to an object that the language never constructed. This kind of reinterpret casting, where you get raw binary data and turn it back into an object, if it ever stops working, everyone's code will stop working. So you can kind of rely on the wisdom of the crowd, as it were, for this to keep working. However, we will soon get I can spell that right. Right. Start lifetime as. This is in C++23, but no one has implemented it yet, as far as I'm aware. I don't think any compilers have this. This gives a void pointer and turns it into a T pointer. This basically legitimizes this. It basically anoints it with holy water, such that it is no longer undefined behavior. So once we get this, everyone's life becomes a lot easier. The correct way is to memcopy it. But anyway, that's a discussion for another time. So always prefer static cast. Use reinterpret cast when you have to. Just be wary that reinterpret cast has a lot of bear traps waiting for you. C-style cast is the really dangerous one. You should definitely never use that, because in C++, a C-style cast has a predefined, it basically tries everything. It tries a static cast, and if that doesn't work, it tries a reinterpret cast. If that doesn't work, it basically goes through a whole list of things it tries, and it gets really gnarly. And it might fail early one when it actually pass a future one because the precedents and the rules are just, you should avoid using. I would say there is no reason to use C-style cast in C++. Reinterpret, the actual usage, the use case for me for reinterpret cast is serialization. It is well defined to reinterpret cast any pointer to a char pointer or an unsigned char pointer or a stood byte pointer. That is literally the way you get the byte representation out of objects. So going from anything to a byte pointer is fine. Going from anything to anything else is potentially undefined. Like here, what I've got here is because I now have access, I have a point. From here I will get a pointer to an SDBI UC object, right? But the program has never constructed this. The program has no understanding of this. So the fact that you can get a pointer to something that was never constructed is technically undefined behavior. And you can also violate the strict aliasing rule. So it is undefined behavior in C++ to have a pointer of two different types pointing to the same address. That is undefined behavior. It's called strict aliasing. So you can violate that quite easily with reinterpret cast. So there's a whole host of misery that goes along with it. It's basically, don't reinterpret cast until you have to. If you go to reinterpret cast and search for undefined, there's 12 matches of undefined in the doc page for it. So yeah, we are using OpenGL. That is correct. We are using OpenGL. Right. Actually, where's YouTube? I think I can give out some free. YouTube allows me to gift memberships. Hello? How do I do it? It's really awkward if I can't do it now. Membership gifting. Right. For anyone on YouTube, thank you very much for coming along. Well, also, if you're on Twitch, also thank you very much for coming along. I can give 10 free 1-month membership gifts per month. So here's 5. We'll do 5 in the next stream, or the next stream I remember. Congratulations. two different types of pointers pointing to the same address with different types. It's trying to emulate a union with two values. Yes, but also you have to remember unions are riddled with undefined behavior. Well, undefined behavior as well, because you cannot use them for type punning in C++. It is undefined. In C, if you use a union, you can change the type after it's been activated to 1, and that is well defined. In C++, it is undefined to do that. You cannot use a union as a cast. Why do I use a unique pointer? Because I have a custom destructor, so it just means when this goes out of scope, it automatically calls this random free function that needs to be called on it. Just in case I throw an exception, I'm guaranteed this gets called. There is also a variant, correct? A type safe union. Let's have a quick look on Twitter. Anyway, but yeah, oh, hang on. Get to my just chatting view, which is exciting. I hope everyone enjoyed that. I think we are only one stream away, hopefully, from wrapping this up. We've kind of got all the mechanics done. We just need to build a separate application which takes all of our assets. So everything in here, bundles them up into a TLV, correctly passes the pings into raw data, not just like smashes a ping file in there, get all that wired up into CMake so it runs when we configure it, and then just rewrite our resource loader to pull from that. I'm hoping that's just one good solid stream, and then after that I kind of want to go on to looking at physics engine, because I think that could be fun. Let's have a quick look, see if there's anyone worth raiding. I like to sort of spread the love around a bit. Is anyone doing C++? There's someone with 2 viewers doing C++. I might send. What else? Ooh. Yeah, but anyway, I'm happy to answer a couple more questions as they come in. I feel sometimes I sort of switch off and there's questions hanging around, so I do apologise. Cool. Anyway, would Win32a to load things faster? No. I mean, we're bound by the terrible, well, not the terrible, the slower library I'm using, which is why I want to offload it. Anyway, hope everyone enjoyed that. Thank you very much for coming along. Twitch, I'm sending you on to someone else who's doing some C++. Show them some love. Hopefully, I have no idea what they're doing, but hopefully it's interesting. Next stream, we will finish this off and then hopefully get onto some physics and then back to some graphics programming. But anyway, thanks everyone for coming along. I had a great time, hope you did too, and I'll catch you Wednesday, hopefully. Cool. See you later.